In the last couple of problems, we have the same issue. We've got i's in the denominator, but there's not just one term in the denominator, there are two. So for instance, in C, we have negative 3 plus I over 2 plus I. The problem is if we multiply by an I on the denominator, it will vanish when we get an I squared, but it will pop up in the other term, so that's not good enough. So what we're going to use is a fancy term. It's called the conjugate. And the conjugate is to basically take the opposite sign of whatever you have on the bottom and multiply by that. So our conjugate here is we have 2 plus I on the bottom. So its conjugate is going to be the same thing but with the reverse sign in the middle, which will be 2 minus I. So that's what we're going to multiply our denominator and numerator by, because remember, we're worried about there not being any i's in the denominator. We don't really care about the numerator, the top. So I'm going to multiply the bottom by a 2 minus I, and I have to do the same thing to the top, multiply the top by a 2 minus I. And then let's see what happens. Well, what we want to do is make sure that the bottom works out properly first, because it was the thing I was concerned about anyways, that I don't end up with i's in my final answer on the denominator. So I need to multiply out my denominator first to make sure that the i's really do vanish. Everything's not going to cancel out, but there shouldn't be i's. So how do I multiply these two pieces out? I need to FOIL. So I'll do my 2 times my 2, which is 4 first. Then my 2 times my negative I, which is negative 2I. Then my I times my 2 is 2I. And then lastly, I have my I times my negative I, which is negative I squared. And you'll see that not everything just cancels out completely, but it does work out nicely. So what happens is we have a negative 2i and a positive 2i. Those are opposites, so those will cancel out. However, what we will notice is we still have some stuff down there. We've got a 4, and we still have a minus I squared. Well, what do we know about the I squared is that the I squared can get replaced with a negative 1. So let's replace the I squared with a negative 1. Well, then what do we have? We have minus a negative. That'll just turn into a plus or a positive. Well, 4 plus 1 down there will now turn into just the number 5. So that worked out. And I wanted to make sure it worked out. Not everything canceled, but there aren't any i's down there, which is what mattered. Now let's take a look at the top. Let's multiply out both pieces on top. So we've got a negative 3 plus I and a 2 minus I that we're multiplying out. So we'll multiply out the negative 3 times the 2, which will give us a negative 6. And then the negative 3 times the negative I will turn into a plus 3i. And then I've got my positive I times my 2, which will be a plus 2i. And then my positive I times my negative I will give us a negative I squared. So let's see what happens here. We have our negative 6 right off the bat. That's going to stay the same. Then we also have, let's see, a 3i plus a 2i, which will give us 5i. And then we have a minus and an I squared. Now we just said it just a couple seconds ago when we were doing our denominator that I squared is negative 1. Well, be careful though. If we replace the I squared with a negative 1, we end up with a minus a negative again. Just like when we did the bottom, which will turn into a plus or a positive. So what that means, we actually have on the top here is a negative 6 plus 1 now. Well, negative 6 plus 1 is a negative 5. We also had our 5i that was already up there that needs to get carried down. So I have, as of right now, a negative 5 plus 5i. which I can now factor. Notice I've got a -5 and a 5, so I can factor out a common factor of 5 on top, which will leave me with a 1 plus I on the top, and we still also had a 5 on the bottom. So just like the other ones, I can cancel out the 5 from the top and the bottom, or reduce them to 1s, however you want to look at it. But all that leaves us with is our final answer, which is just what was inside the parentheses, the 1 plus I is our final answer. But notice, there are no i's on the denominator, and we are actually done. Now let's take a look at D. In problem D, we have -6 plus 8i over 1 minus I. And remember what the goal is here. We're not actually dividing, we're just trying to get rid of the I from the denominator using what's called a conjugate. Well, remember, we find the conjugate or the opposite of what was on the bottom. Well, we have a 1 minus I on the bottom, so its conjugate or opposite would be 1 plus I, just switching the sign in the middle. Well, that's what we're going to multiply the bottom by, the 1 plus I, and we have to do the same thing to the top, the 1 plus I. We'll get multiplied by that on top and bottom. So, but I want to make sure that the bottom, which is what's most important, works out first. So let's FOIL out the bottom first. So we'll start out with a 1 times 1. A 1 times I, which is I, and -I times a 1, which is -I, and then a -I times the positive I, which is a -I squared. So let's see what that does for us after we have FOILed it out. Well, notice right away we have a plus I and a minus I. Those are opposites. They will cancel out. We also have our 1 and our minus, but then we have our I squared. But remember that I squared can be replaced with a -1. So we're replacing that I squared with a -1. But then we get minus a negative. Remember, when we have two negatives side by side, they turn into a plus or a positive, which means now I've got 1 plus 1, which means that entire denominator is just going to turn into a 2, which is really all I care about, is that there's no I on the denominator right now. That's what we needed. However, we still need to multiply out the numerator, the two binomials up there. So we'll start out by multiplying out the -6 from the -6 plus 8i, and we will get, let's see, a -6 times the 1 is a -6. -6 times the I will give us a -6i. Then the 8i times the 1 will give us a regular just 8i. And then the 8i times the regular I will give us 8i squared. So let's see what happens here is, well, we have a -6i and a positive 8i. Those are like terms that can just be added normally. -6i and positive 8i will give us a positive 2i. We already have our -6 that was out in front. We also have a positive 8. And right next to that positive 8, we have an I squared. Remember, we can replace that I squared with a -1. So when we replace that I squared with a -1, then we end up with, let's see, a 8 times -1. Well, let's see, 8 times -1 now is a -8. Well, then I can just combine like terms, because then I have a -8 and a -16, which when added together is a -14. And I can't forget that I did have a 2i up there from when I combine like terms, so I'm going to bring down my positive 2i. However, this can be reduced by factoring. First of all, I need to look at everything on top and see if there's anything I can factor out. Well, notice I've got a -14 and a positive 2i. What do they have in common? Well, a negative 14 and a positive 2 are both divisible by 2. So I can factor out a common factor of 2. So 2 will go into negative 14, negative 7 as negative 7 plus, pulling out the 2 from the 2i will just make the 2 come out and we'll leave you with just the I. However, we did have a 2 on the denominator. Now we can reduce that. We've got a 2 on the top and a 2 on the bottom, which can be divided out or canceled out. Either way. They'll both turn into 1s or disappear completely, which means our final answer here will just be what's inside the parentheses, the negative 7 plus I. That's our final answer, the negative 7 plus I. And that's it. That's the last thing that we're going to go over regarding i's and complex numbers. Now, as a warning, this stuff actually will get used in this course. I know you've seen i's before, and generally it just gets used for when you do quadratic formula. This is actually going to get used off and on throughout this entire course, and actually very heavily towards the end of the course when we do something called polar coordinates. So this is very important. Do spend time on it.